All right, so this is just going to be a quick video, hopefully quick, on how to set up and solve one of these word problems. And this is standard 7.1. So I'm just going to read through it. So Jenna's got $90 in her account, and she wants to spend at most on this. I think that word's going to be pretty important. The $90 is pretty important. She loves shoes, and each pair costs $14, and she already bought a dress for $4. Okay, when I wrote that problem, that was supposed to say 40, so let's change that, because who can buy a dress for $4? Although maybe she went somewhere like a thrift store, in which case, great find Jenna. But let's change it to 40 just so that the numbers are maybe a little nicer. Okay, so she already spent $40, and now the question is, how many shoes can she afford to bite? Man, Jenna's on a roll. Buy. All right, define a variable, write and solve an inequality, how many sandwiches he can buy, which is obviously supposed to say shoes she can buy. You know, great job, Mrs. Moon, on writing this problem. Show your work and interpret the solution. Okay, so what this really means is what you don't know is what you want X to represent. So X is what the story is about, which is we're trying to figure out the number of shoes. And so again, it's not just shoes. I mean, if you want to write that, I know what you mean and things like that, but what the color of the shoes, the weight of the shoes. So really we should be a little bit more specific. So the number of pairs of shoes is really what you're trying to figure out. Okay. So if you're going to write the inequality, you can solve this in lots of different ways. I don't really care about a step-by-step procedure that you use as long as you get the correct answer in the end. But here's one way to get, all the points for this problem, which is, listen, she's got to spend $14 for every shoe, and she already spent $40. So together she wants to reach her goal, right? So she spends $14 per shoe. She bought the one dress for $40. And so together, so I'm assuming that that's going to be a plus sign, which I think is a good assumption because we're trying to put these two money values together. And together, she's got 90 in her account. She wants to spend at most. So this is like the goal, and her goal compared to the 90 is to stay underneath it. So this, her goal, this is like her max. We want to stay underneath. And so the best way to write underneath is less than or equal to. Because it's okay if she spends $90. That's why we add the line there. Now, 14 plus 40, okay, that's a nice little statement, but it really only tells me that I'm buying one pair of shoes, the one group of 14. And I'm not really sure how many pairs of shoes that she needs. Plus, we're missing the whole variable. And so $14 for the shoes just means I need to throw an X with the 14. Because who knows how many 14s I'm going to have. I could have, 4 pairs of 14 or 1 pair of 14. We don't know. Okay, so that's my statement. I have to sneeze. Hold on. Sorry. Okay, so I've got my goal and my max. And so now I'm just going to solve it. All right, so what's X with? How are they connected? And how do we undo it? So I'm going to color code this. What's X with? How are they connected? And how do we undo it? And so we always undo addition and subtraction first before we rip off that 14. So furthest thing away from X, the 14 and the X are super attached. So this seems like an easier manipulation. So to undo that 40, we subtract 40 from both sides. What you do to one side, you do to the other to keep things balanced. 90 minus 40 is 50. 40 minus 40 is nothing. That's a 0. So bring down the 14x, and the 40s together make a nothing, so I don't have to bring them down. Okay? All right. Same kind of thing. What's X with? How are they connected, and how do we undo it? So the 14 is connected by multiplication, which we undo by division. Since we're dividing by a positive number, the symbol stays the same. 14 divided by 14 is 1, which I don't need to write unless you'd feel like writing a 1 there, but you don't have to write that 1. And then I just have to figure out what 50 divided by 14 is, and I could split screen, but I'm just going to show this in Desmos. Hopefully it pops up. So 50 divided by 14 is 3.57. So I'm just going to round to 3.57. And that is what your solution is. Now, that's supposed to be a decimal, okay? We don't pick nice, always easy numbers. That's not really how life works out. Tends to be pretty messy. And so really what the issue is trying to figure out what that really means. So Jenna can buy X, which is less than or equal to 3.57. So now we have to make it related to the story. So when it says interpret the solution in a sentence, you are not going to translate this. It's not, this is what you're not going to write. X is less than 357. Like that is not what we want, okay? We want this final answer to be related to shoes, to the story, meaning, context, words. That's what we're looking for. So the number of shoes she can afford to buy is, that's not how you spell buy, B-U-Y, is less than 3.57. So really she needs to buy less than 3.57 pairs of shoes. You can't buy 3.57 pairs of shoes. So what you can really say is she can buy less than 3 pairs of shoes. Either way, I would accept both those answers. I don't care if you tell me that the number of shoes she can buy is less than 3.57 or less than 3. Can't write less than 4 because she can't afford 4 pairs of shoes, right? Her answer has to be less than or equal to 3.57. So if she buys 4 pairs of shoes, she's going to go over, right? Let me just show you. So each pair is worth 14. So if she buys 4 pairs, that's $56 plus the $40 for the dress. See? If she buys 4 pairs of shoes, she's over her limit. So up to 3 pairs of shoes. All right, hope that helps.